Hello again from Digicool Things. Earlier I posted an article and video on my TMS9929A Video Display Processor VDP Rediscovery. This included designing an alternate Retro VRAM solution, which I then implemented as a breadboard prototype and also verified successful operation. Having built an MECB Backplane and my first actual MECB card, a prototype card, and also having proved the PLD-based address decoding logic, now seems like a good time to implement my TMS9929A based VDP circuit design onto a PCB as my first MECB video card. I'll also be able to use the header pins on the MECB Prototype Card to allow me to easily hook up the same Arduino test setup, which I'd been using with the breadboard circuit. This will allow an initial test of the PCB design with a known working test setup. Ultimately, we'll, of course, add our first MECB CPU card to the project. Then we'll be well on our way to our first full MECB-based Retro 8-bit computer design. But before I get ahead of myself, I'll focus on the creation of my first MECB video card, a TMS9929A VDP-based alternate Retro VRAM solution video card. On my workbench, I currently have the breadboard setup that I built and proved operational in my earlier TMS9929A Rediscovery video. You'll find a link to this earlier video in the description, as I'd suggest watching that video first, where I discuss the design in detail. So let's dive into the KiCad schematic. As you can see, the TMS9929A and 4464 based VRAM solution is basically just as I'd earlier prototyped. All that I've essentially added is the MECB bus connector, as well as a PLD for address decoding. Also for the output, I've added a mini-DIN RGB connector, as well as a stereo audio input to allow sound pass-through to the mini-DIN RGB connector. The choice of which RGB connector to use pretty much boiled down to choosing between the use of an 8-pin mini-DIN for the more recent XRGB Retro RGB connection cable standard, or instead using a 9-pin mini-DIN as used by the Sega Genesis 2 or Mega Drive 2. This decision proved reasonably easy. I quickly found that 9-pin mini-DIN PCB mount connectors and retro Sega Genesis 2 RGB cables are very easy to find and are relatively inexpensive, whereas 8-pin mini-DIN PCB mount connectors and pre-made XRGB cables were harder to find and considerably more expensive. The only downside with choosing the Genesis 2 standard is that the commonly found Genesis 2 RGB SCART cables include 75 ohm output resistors within the actual cable assembly. This meant either modifying the TMS RGB board's 75 ohm SMD output resistors with bypass links, or swap them out for 0 ohm resistors, or modifying the Genesis 2 cables to remove the resistors. I've chosen to remove the resistors from the cheap pre-made Genesis 2 SCART RGB cables, as this is reasonably easy to do, and this approach retains the resistors on the TMS RGB board, which is, quite frankly, where the 75 ohm output resistors belong. So let's take a look at the PCB layout. As I've shown in the previous MECB videos, I created this KiCad project by using the standard MECB board KiCad template. This sped up the process significantly by letting me start off with a predefined PCB with mounting holes and with the bus connector and address decode PLD already in place and the PLD's traces already routed. As you can see, the rest of the PCB layout came together relatively nicely, with plenty of space available on the MECB standard 100mm square PCB size to allow for relatively easily trace routing on a simple and cheap 2-layer board. So these PCBs were ordered from JLCPCB, and here they are. Let's take one out. Okay, here's the PCB. That's the underside. And if I flip it over, there's the component side. Now this is actually V1.0 of the PCB. Since ordering this, I have made a couple of small changes, which will make for a version 1.1. But this version does equate to what I initially tested as working on the breadboard. So this will be fine for testing the PCB circuit. And the modification for V1.1 are relatively minor. So let's put the first one together. I'll start off with the resistors and then insert the regular IC sockets. Then I'll fit the capacitors and the crystal, after which the DIN 41612 MECB bus connector and also the zero insertion force IC socket that I'm going to use on this board for easy swap outs of the address decode PLD chip. Finally, we'll solder in place the video and audio connectors. So with that bit of magic assembly completed, without me boring you with my soldering, we're nearly ready for some testing. In terms of assembly, the only part I haven't mounted yet is the TMS RGB module, which mounts on the back of the PCB. I'll show you how the TMS RGB module mounts, but I'm intentionally not mounting it as yet, as this PCB is, of course, untested at this point. So let's move this aside, make some space. So there's the solder side. So as you can see, if I grab a TMS module, this simply just drops in place behind the IC socket. And is soldered in place via the relevant connection pins. Then I've implemented a 4-pin right angle PCB header to connect the TMS RGB outputs back to the PCB. So that slots in there. And once the signals are back on the PCB, they are routed to the mini DIN output connector. Hopefully you can see that. So it makes a nice tidy solution for a high quality output from the TMS VDP chip. But for now, I'll just temporarily wire a TMS RGB module on, swapping across the module I've been using from the breadboard circuit. This will enable me to initially test the PCB design as working before more permanently mounting the module. So I'll get the module wired in now. So I'll grab the module off the breadboard, just pull that out. As you can see, there's only 5 connections. You've got the 2 power connections and the 3 video input connections. Okay, with the TMS RGB module wired up, I'll get the regular ICs inserted. Let's flip this over. First, the 74HCT04 hex inverter. Then the 74HCT244 octal buffer. Then a couple of 4464 dynamic RAMs. Finally, the TMS9929A VDP itself. Now for testing, I'll use the MECB Prototype Card connected to the MECB Backplane's horizontal connector. This will give me easy access to the MECB bus header for connecting up the Arduino test setup. So let's bring that in. This will give me easy access to the MECB bus header for connecting to the Arduino test setup. As the Arduino was programmed to connect directly to the TMS VDP chip, and the chip select pins are now routed on the PCB via the address decode PLD, I've decided to program a PLD so that a couple of the address lines are simply passed directly through to the VDP's chip select read CSR and chip select write CSW pins. This will enable me to initially test the full VDP PCB without making any changes to my Arduino code. Therefore, it should hopefully just replicate how it was working on the breadboard, only now with the full 8-bit wide video memory in place. Remembering that for the proof of design breadboard prototype, I had just connected up a single 4464 DRAM chip, which provided just the low nibble of each memory byte. So let's now get the Arduino connected up and the temporary pass-through PLD in place. Okay, so I've now programmed the PLD with the simple pass-through configuration that I showed earlier. This effectively just connects address line A4 to the chip select read CSR and A5 to chip select write CSW. Note that the VDP's mode selection input pin is already wired directly to address line A0 in this circuit. So let's now insert the PLD into its serial insertion 4 socket. Next, I'll swap the Arduino across from the breadboard circuit. To do this, I've got some male to female DuPont leads. So I can jumper from the Arduino's female headers to the MECB Prototype board's bus connection male headers. So referring back to the Arduino sketch notes, we have our required Arduino port connections. If we map these to the MECB bus pins, we end up with the following. So let's get the Arduino swapped over. Okay, I'll move the VDP board out of the way temporarily. And I think I'll just unplug all the leads from the Arduino board from the breadboard. Right. Of course, there's one more connection which I've omitted to put on the signal mapping, and that of course is the common ground connection between the Arduino and the MEC bus. So let's do that first before I forget. I'll grab the black wire and jumper that into the Arduino's ground pin. and the MEC bus ground is on either A32 or C32. Let's move that out of the way a bit further. Okay, then I'll grab a bunch of 8 wires and these will do for the Arduino D2 to D9 pins which we're using. So I'll plug all those in. And then we need 4 wires for the A port. So I'll grab another 4 and let's get the A port connected. That's A0 through A3. Now to jumper those to the MEC bus pins, we'll start from the left, so let's find D2. D2 goes to C5. D3 goes to A8. And D4 goes to A5. D5 goes to A2. D6 goes to A3. D7 goes to C3. And we're up to D8 goes to A7. And D9 goes to C31. Then we have our Arduino port A. So A0 goes to C5. No, sorry, A0 goes to C2. A1 goes to C14. A2 goes to C4. And it just leaves A3, which goes to A4. Right, we should be all connected. I'll just need to put this over the side so we can reach the micro USB port easily. Now I guess it's time to plug our VDP board into the MEC bus main board. So we can choose any socket. Let's throw it in there. Finally, for this test, I'll connect my GBS control VGA converter power input to the spare MECB Backplane screw terminal power connector, which is very convenient. So I'll grab the power out of the breadboard, run those wires over here. and get them connected to the screw terminal. It's ground and 5 volts. Now, because those are spare input connectors, it does mean that the GBS control board won't be switched through the power switch, but that's okay. With that all done, I think we're all ready for an initial test. I better hook up the monitor. And I'll need my 5 volt USB supply to power the main board. Currently we're switched off. Of course, plugging that in will power up the GBS control straight away. So, the moment of truth. Let's power it on. Make sure we don't get any magic smoke. Right, we should have power on. And the final thing will be to connect up the Arduino. Got a micro USB lead that I'll plug into the computer. And let's power up the Arduino. And it looks like we have success. We have the expected test pattern as we saw on the breadboard prototype in the last video, but now being generated by a new MECB VDP video card. So the last step to complete this board will be to solder on the TMS RGB module, then modify a Genesis 2 video cable to remove its embedded output resistors. Then I should have a nice SCART lead to plug directly into my analog CRT, which will be very interesting to finally see the good quality VDP output displayed on a retro CRT display. Also, now that I have the full 8 bits of video memory available, I'll be able to play a little bit more with the Arduino code to make use of the second nibble, and to also make sure the Arduino code is now testing all 8 bits of the video RAM. But for now, I think we'll call that a success. So now I'll be able to turn my attention to an MECB CPU card so that we can drive the VDP card directly from a retro 8-bit CPU instead of the Arduino. That's it. Thanks for watching.